In the last lesson we learned what the range mapper is, and in this lesson we want to create a little example scene with the options of our range mapper. So let's create a sphere, make it a little bit smaller. So what I basically want to do is I want to create a ball which I can move from left to right, and the ball should automatically jump like this. Just a bouncing ball. So let's try this. We have our cube. I will create an XPresso tag. Not a cube, it's a sphere, of course. I will create an XPresso tag. And maybe let me undock this, that we could have floating window here. Okay. First of all, we need our sphere. And we need we move it in X direction, so we need the X position. Coordinates, position, X. And we need our sphere again and create an input port. Coordinates. Let's move it to the left. Input port, coordinates, position, Y, because I want to drive the Y position of my sphere. And in between we need our new best friend, the range mapper. Okay, perfect. Let's connect them. And take a look at them. Okay. I think I will dock it again here. It's much better to see everything. So, what we see right now, if I move it to the right, it moves upwards. So, that's not exactly what we want. Not like this. So, we will have to check our range mapper. Okay, first of all, we need to define our ranges. So I would say if we move it in X direction, maybe something about 100 centimeters. Yeah, so it's small jumps, maybe 150. Okay, if I move it 150 centimeters to the right, I want the ball to move upwards. So input lower is 0 because I start at X 0. And upper is, what was it, 100 or 150? 150. Okay. Perfect. So now we need to define how high he should jump. So maybe let's say 100. So that's actually not what we need, because if I now start to move it from the left to the right, he will continue to move upwards. So what we need to do is to make a curve. Something like this. So if I move through my input range on this side, he will jump up and come down again. Let's try this. Up, down, up. Oh, what happens here? Oh, we have a problem. Because he does this curve one time, and afterwards he will just continue to map these values linear. So we have to change that. For this we have modulo. The modulo function takes our input range, and when we move through our input range, we will map our output range, so this curve. If we start to move more than 150 centimeters to the right, he will not continue to map something somewhere. He will jump back at this curve and do this action again. And when we reached 300, so 2 times 150, he will again jump back. So he will constantly jump back in this curve and do this again and again and again. So this is what we need, modulo. And if we now start to move, we see, nice, he's jumping. So, but basically we don't need this curve to be smooth like this, more like because he's bouncing onto the ground, so we need a bounce. This looks better. Boink. Nice. So if we take a look from the side view, I want my sphere always to touch the ground. So if we have our ground plane here on this red line, I want the sphere always to touch the ground and don't intersect with the ground. And I want this to be, no matter how big my sphere is, it should be automatically reassigning this value. So let's try this. To define at which height my sphere starts, we need to define the output lower, so where it starts. If my sphere has a size of, let's make it at 50 maybe, so my radius is 50 centimeters, so it has to be at also at 50 centimeters height. So let's check back our range mapper. I will lock this window here that we see it all the time. And input lower, let's type in 50. So perfect. Now we're jumping always onto the floor. But if I change the size of my sphere, it won't work anymore. So we have somehow to tell XPresso to use the radius of my sphere in this output lower field here. So let's check that out. Open up XPresso. And we will create a second range mapper. Oh no, sorry, we don't need a range mapper here. Let's take our range mapper, and we want the output lower as an input port. So output lower. And we want the radius of the sphere to be our output lower. Object properties, radius. Just connect it. Very nice. And if I now refresh my view and make the sphere smaller, it should work. Boink. Works very nice. The problem is that our output lower is now driven by XPresso, but not the output upper. So if I make my sphere really big, it won't work anymore because the sphere won't jump high enough. So we have to define this one also. So let's go back to XPresso and create an input port for output upper. And I think I want the ball always to jump maybe 4 times his own radius. So if we take a look from the side, so this is our sphere, this one is the radius, and I want him to jump 4 times this radius. So 1, 2, 3, 4, maybe this high. So we have our radius and we have our output upper, and I want this radius to multiply with 4. So we need a math node. Set this one. Set the math node to multiply and connect the radius. You don't need to connect 2 numbers all the time, because right now I just want to type in a custom factor. So you just connect the first port here and type in the second one here. So 4, and connect this one to output upper. Now if I change my radius, it works very nice. So now my ball is always jumping on the floor, and if I change my radius, he will jump higher, but he will always touch the floor. So if I type in a whole number, something like 200, no, 300, then he's touching exactly the ground. So always at 150 centimeter steps, and it's fully dynamic. Very nice. Cool. Set it to 0, so it touches the floor. And of course you can just select the range mapper and customize this curve to define how the jump should look like. So you could also do something like this, that he's longer in the air. So he's jumping up pretty fast, staying there, and then falling down again. So more cartoony maybe. Yeah. Nice. So in this lesson we learned how we can use the range mapper to build a little setup. And in the next lesson we will try to use a squash and stretch deformer to give our ball a cartoony look, and we want to drive this deformer also with our range mapper.